Good evening, everyone. We're going to go ahead and finish out this part of the unit. We'll take our time to speak about percent yield. Now, percent yield is going to be our basic idea of efficiency, of how much did we actually make compared to what we were supposed to make. Now, our goal, of course, by the end is that you'll be here at level 3. I'll be able to determine the efficiency of a reaction by calculating the percent yield for a given reaction. You may be starting off with a basic idea of how we're going to go about this, which is perfectly fine. You might be at a level 2.0, or you might be again at that level 3.0. I have no idea. I'm at the basic bottom level. I'm ready to start and move on. So go ahead and rate yourself, and we're going to go ahead and jump into this head first. Now, our objective, of course, is to be able to calculate theoretical yield, percent yield, and the amount of excess reactant that remains at the end. Now, the concept of yield. This is going to be different than the type of yield in driver's ed. Of course, that part makes a little bit of sense. We're actually looking at the amount of products that we make in a chemical reaction. There are 3 main types that we're going to deal with. Actual yield, what you actually get in the lab when the chemicals are mixed. Theoretical yield, which is what the balance equation tells you should be made, and percent yield, which is going to be actual over theoretical times 100. Okay? Now, the theoretical yield is what we've actually been calculating this whole time. So when we did our stoichiometry and we said that this one was our limiting reactant and we got our values out, that was actually our theoretical yield. The actual yield is going to the lab and we actually put this into practice. So let's take a look at what we have here. We have 6.8 grams of copper is produced when 3.92 grams of aluminum react with an excess of copper 2 sulfate. Now, 2 things I want to point out. It tells you this much is produced when this amount goes through a reaction. So this, in this case, is our actual yield. Sometimes it'll be given to you at the beginning. Sometimes it'll be given to you in the middle. But the key is it tells you how much is produced when a certain amount is actually going to react. So, what is the actual yield? First thing we need to figure out, we see that our actual yield is 6.79, or 78, sorry. What is the theoretical yield? That's where the work is going to come in. So, taking a look at what we have. Now, the answer was there on the screen, 13.8. We want to check and make sure that we actually come out with the right pieces. So, 3.92 grams of aluminum, 26.98 grams to 1 mole. By this point, this part should be becoming very, very easy for you to deal with. So, next to our mole ratio, we're trying to find out how much copper, so that means 2 moles of aluminum to 3 moles of copper. And again, molar mass of copper 63.55 to 1 mole. Okay? Now, notice in this case, since it only gives me one quantity to see how much is going to be produced, I only have to do one table. So, plugging it in, 3.92 divided by 26.98 times 3 divided by 2 times 63.55 gives me 13.85. So that actually be what, 13.9. Now, this is the theoretical yield that we're dealing with here. Now, we need to find that last part, which is what is our percent yield. Well, we said it's going to be actual over theoretical times 100. So in this case, it's going to be 6.78 over 13.8 times 100. 6.78 divided by 13.8 times 100. And I came up with on my calculator approximately 49.13. Oops, sorry, my handwriting got a little outrageous there. Approximately 49%. Let's check and see if we got according to what's here, 49.1%. So when I have gone through this reaction, I've done all this and I came up with 6.78 grams. I was supposed to get 13.8. Is that a good investment? Imagine if you were to put in $10,000 to a company and it said that you're guaranteed to only get half of it out. Do you think that's something that you would want to invest in? Probably not. So we want to look at what are the things that we can actually do to improve those. That's what we're going to take some time to do in class. Now, percent yield again tells us how efficient a reaction is. It cannot be larger than 100%. It's not possible. Theoretical yield will always be larger than the actual yield. Now, this is the why. We can have impurities in our reactants. We also have some side reactions that are going on, and depending on how we're actually separating out our materials, we can have loss of product and filtering and transferring containers. This will always sort of give us that less than 100%. But if we can minimize these things and we can get higher and higher in terms of our yield, we have a better chance of being able to make money off of our product, whatever it should be. Now, what I want you to do is go ahead and rate yourself. Where do you fall in this whole thing? Do you understand? Do you feel like you could actually determine and explain a little bit about how we can increase that efficiency? Or are you still just struggling with the idea of what is percent yield? My hope is that we've been able to, again, bring you up a couple of levels, or bring you up a little bit so that you're better prepared for what's yet to come. Hope that you're preparing for your tests and quizzes as we go along. Bring your questions in class and we will be ready to go through them and make sure that you understand. Have a good evening and see you then.